Good morning. This lesson is for my Trig-Precalc classes, but before I get started, I want to say I hope that everyone's doing all right up there. I'm not sure how I'm going to title this lesson, but I'm going to title it how I title it in the title. But what I am sure of are two goals for the day. Our first goal is going to be to find tangent of theta, cotangent of theta, secant of theta, and cosecant of theta. And after that, we're going to calculate tangent of 30 degrees. But I'd like to review something with you real quick. Cosine of theta is a fancy way to ask for the x-coordinate at an angle or length on the unit circle. Similarly, sine of theta is also a fancy way of asking for the y-coordinate at an angle or length on the unit circle. So that's what we need to remember. Cosine is the x-coordinate, sine is the y-coordinate. Alright, so let's go ahead and jump into our first goal of defining these trig ratios. The tangent function or ratio, tangent of theta, is defined as sine of theta divided by cosine of theta. And that's a real fancy way of saying that it's the y-coordinate divided by the x-coordinate at a certain angle or length on the unit circle. Cotangent of theta is defined as sine of theta divided by cosine of theta, right? Cotangent, cosecant. That's a fancy way to say that I want the x-coordinate divided by the y-coordinate of a angle or length on the unit circle. I'm trying to think, doesn't happen. You're a little confused here. Secant is defined as secant of theta equals to 1 divided by cosine of theta, which is a fancy way of saying 1 divided by the x-coordinate of an angle or a length on the unit circle. And finally, cosecant, which is defined as cosecant of theta, is 1 divided by the sine of theta, which is a fancy way to say 1 divided by the y-coordinate of an angle or a length on the unit circle. So I'm going to go ahead and check off the first goal of defining those four. I'm going to count those 4 trig concepts. All right, next goal, second goal. Let's calculate the tangent of 30 degrees. So the coordinates at 30 degrees are square root of 3 over 2 and 1/2. So we get tangent of 30 is equal to the y-coordinate divided by the x-coordinate. Pretty simple to set up, but we are not allowed to have a fraction in the denominator, so here's how we're going to fix that. So that's not allowed. So we have tangent of 30 degrees is equal to the y-coordinate at that angle divided by the x-coordinate at that angle. Now, I'm not allowed to change a value. I'm only allowed to multiply by 1 because any number times 1 is still that number. But we can get creative with how we multiply by the number 1. Now, I'm going to specifically take the denominator and I'm going to flip it over and I'm going to put that in the denominator and the numerator. And remember, any number divided by itself is technically equal to 1. So I am actually going to multiply this by a very fancy version of the number 1. So this is going to be 2 over square root of 3, and that's dividing into 2 over square root of 3. This is technically 1. So I'm not changing this value, but because I'm making my version of 1 look like this, what this is going to allow me to do is this is going to allow me to cancel out those and cancel out this, as well as the numerator. And the denominator, the numerator, let me say it again. The numerator and that denominator cancel out, leaving me with a new numerator denominator in the numerator of the new fraction. Oh, the tongue twister. All right, so whatever was not canceled out is my 1 divided by my square root of 3. And this actually all turns into the number 1. And anytime you have a number divided by 1, you get that number again. So now we have 1 over the square root of 3. But we have a square root in the denominator, and that is not allowed. And here's how we're going to fix that, which is called rationalizing the denominator. So again, we're not allowed to have a square root in the denominator. So again, what we're going to do is we're going to exploit multiplying by 1, but we're going to pick a version of 1 that will allow us to cancel out that radical. So what we're going to do is we're going to have our 1 divided by the square root of 3. Then we're going to write a version of the number 1 that looks like this. Square root of 3 divided by square root of 3. Now 1 times square root of 3 is going to be equal to just the square root of 3. And square root of 3 times square root of 3 becomes square root of 3 squared. Now remember that squares and square roots cancel each other out. So what we're going to have here is the square root of 3 divided by 3, and that's what tangent of 30 degrees is equal to. So this example which I picked has both potential issues with the ratios that we're going to get. The first issue that we're going to have is a fraction in the denominator. The second issue we're going to have is a radical in the denominator. So knowing what we did on this problem will allow you to calculate the tangent, cotangent, secant, and cosecant of any point that we have on the unit circle, because you're going to get either a fraction in the denominator, a square root in the denominator, or a combination of both. So whatever I did here, you can apply that to the other points on the unit circle. So I'm going to go ahead and end this here. I think I accomplished everything I needed to show you in order for you to do this current homework assignment. So again, I'll just go ahead and end it. I hope everyone is doing all right out there. Have a great day, everybody. Go Bears, beat the Ducks. Bye-bye.